What is logical VTEP? How can you achieve dual homing for an end host connected to VXLAN EVPN fabric? And how do you configure all of this using enterprise SONiC? This is what we are going to cover in this video. So what is a logical virtual tunnel endpoint, or LVTEP? It's basically a VTEP that is representing an MC lag domain. So in this case, leaf 1 and leaf 2. Now for routing protocols, both leaf 1 and leaf 2 have their own unique identity. You will see that we will assign unique loopback 0 IP addresses to both of them. But from VXLAN routing point of view, these two leaf switches will appear as a single virtual endpoint or logical VTEP. Let's look at some configuration commands. Now I have already recorded videos covering OSPF configuration as well as video for VXLAN with BGP EVPN configuration. So I won't bore you with all the details I have already covered. And if you haven't watched those videos and would like to view that now, links are in the top right corner of this window. In this session, our network design is something like this. We have OSPF as our underlay protocol and BGP EVPN as our overlay. It's the same autonomous system number, so our spines will perform the route reflector functionality as you would expect in an iBGP environment. Now, first important point to remember in this configuration is that both leaf 1 and leaf 2 will use identical Vtep IP addresses. And this is the command that we use to define our Vtep IP under interface VXLAN mode. The source IP, and in this case 100.1.1.1. This will be the same IP we will configure both on leaf 1 as well as on leaf 2. It is also recommended that we have a route pairing between the two MC lag peers, especially if we are going to have some single attached endpoints. In this scenario, I will leverage my peer link for this connectivity, and since peer link is a layer 2 link, I will create a transit VLAN for my OSPF pairing. It's vital that these SVI for transit VLAN on leaf 1 and leaf 2 should have unique IP and MAC addresses. Well, we can assign unique IP addresses to SVIs on both switches, and system will assign unique MAC addresses, right? Not in this case. Because these switches are part of an MC lag domain, ICCP will make sure that this VLAN, in this case VLAN 998, has identical MAC on both switches. Not good for us because this will break our communication. So how do we tell ICCPD that although these SVIs are in the same MC lag domain, but please don't assign MC lag gateway MAC to these? Answer is by configuring this command, MC lag separate IP. A very important command for a transit VLAN use case. There is more configuration that we need on leaf, and I will show you that in the next section when we will jump on the lab. Let's look at the spine configuration now. And this is all the configuration we need to configure spine. Here we are using BGP dynamic neighbor feature, this listen range command. So we are instructing BGP that if we receive a pairing request, a TCP pairing request, TCP session request from a BGP speaker in this subnet range, so anything within 192.168.0.x range, and as long as the BGP parameters are what we defined in this peer group, we will form a BGP relationship with that BGP speaker. Now, what is the advantage of doing that? Imagine you have 100 leaf switches in your pod. So rather than defining 100 neighbor statements, you only need to define one statement, this one. Secondly, if you need to add another leaf in your switch, another leaf switch in your pod at a later stage, for example, let me grab a pen. So you want to add a leaf switch later on. All you need to do is to make sure that this leaf has an IP address from this range, and you do not need to make any change to your spine configuration. As long as the BGP parameters are correctly configured, a BGP relationship will be formed. Pretty useful feature, isn't it? Last thing I would like to touch upon is this route reflector client command. So this is how you configure your spine switch as a BGP route reflector on Enterprise SONiC. So that's all from this section. Let's jump on to our lab now. So let's start our lab. As you can see, we are leveraging the same topology that we use for MCLAG configuration video. In that video, we focused on just leaf 1 and leaf 2 mainly. Now we will be configuring all these 5 switches. We already have OSPF running between all 5 switches. We are already learning these loopback addresses through OSPF. We have MCLAG configured between leaf 1 and leaf 2. We have this port channel 100 configured. We have this port channel 1 configured. And we have these VLANs 10 and 11, but at the moment they are not part of any VRF. What we will do now is that we will configure VRF called VRF1. We will put our VLAN 10 and subsequently VLAN 11 in the VRF, and then we will do our Bgp EVPN configuration. So let's start from leaf 1. So on leaf 1, if I do show IP OSPF neighbor, we can see that we have 2 neighbors, and these are to Ethernet 12 and Ethernet 16, which connects to spine. So we have 2 OSPF neighbors, .4 and .5. Okay. Let's have a look at our MCLAG configuration just as a revision. MCLAG brief. So we can see this side is performing the active role, and 0.2 is the peer, which is our leaf 2. And we can see port channel 1 is an MCLAG. Show port channel summary. Port channel summary command gives us the overview of all the port channels, and we can see there's a port channel 100, which is our peer link, and we have this port channel 1, which is an MCLAG. Show an interface port channel 1, and you can see this command, actually MCLAG 1 is the command which made it an MCLAG. We have already allowed VLAN 10 here on this port channel. Okay, very quickly on leaf 2, show IP OSPF neighbor. We have neighborship active with our spine switches, and show MCLAG brief. We have the MCLAG connection already up. Okay, so let's start configuration from the leaf 1. This is the configuration we're going to use. So I'll create this VRF. I've talked about Anycast MAC address in a previous video already. We will put VLAN 10 in a VRF now in our tenant. This is the IP which will be the default gateway for all the endpoints in VLAN 10. This is our transit VLAN, VLAN 998. So this is the VLAN I will use to form an OSPF pairing over this peer link. VLAN 999 will be my IRB VLAN, for my VRF1. So all layer 3 communication will happen through this VLAN. And then I will add this VLAN 998 and 999 on our peer link. Very important. All the VLANs that you create, they should be added to your port channel, including the IRB VLAN. I'll create a loopback 1, and this loopback will carry my Vtep IP, and you will notice that it will be the same IP on both leaf 1 and leaf 2, and then we will move to BGP configuration. So let's start from here, and let's see if I can do all this configuration in one go on leaf 1. Configuration mode. Yes, looks like it is all accepted. Show IP OSPF neighbor. Obviously, no new neighbor is found because VLAN 998 is not configured on the other side yet. But the other configuration should be up now. So show running interface port channel 100. If I look on my peer link, I can see all these VLANs are allowed. Okay, let's do the BGP configuration. This is the leaf side. Okay. Configuration mode. That's my BGP configuration. Show running BGP will show me this configuration. So this is the VRF related configuration, and this is my default VRF configuration. Did you notice that I have these commands here? We add these as a best practice. Always compare med and max med on startup for 60 seconds. So for the first 60 seconds when the router will start up, it will be advertising maximum med value so that we do not attract any traffic. So we allow our routing protocol to converge before a newly started router comes in the data plane. Okay. So this is the routing configuration all done. Let me just make sure this is there. Yes, it is here. Okay. So let's just configure this final VXLAN configuration. So at the moment, if you will see, there is no VXLAN configuration. Show interface VXLAN. Show running interface VXLAN. I wanted show running interface VXLAN. No configuration at the moment. Okay. So that's VXLAN config done. We can do show VXLAN VLAN VNI map. VLAN 10 and VLAN 999 are mapped to their corresponding VNI. I can see. Show VXLAN VRF VNI map. So this is the VNI assigned to my VRF. So this is the VNI which will be used for all the layer 3 communication. Okay, let's do the same configuration on leaf 2. There are going to be very few minor differences. One difference will be here. So we definitely need different IP address on VLAN 998. And this mclag separate IP command, very important. What else? This has to be the same, remember? Logical VTEP. This will be different. So the router ID will be 0.2. This will be same. Router ID 0.2. And that's it. All the remaining configuration will be same. So I'll copy paste it in one go. Okay. Leave to configuration mode. Good. So let's see if our OSPF relationship is up. Show IP OSPF neighbor. And yes, we have now neighborship relationship with 0.1 which is leaf 1. Okay, let's now continue our configuration and let's configure leaf 3. So I have configuration for leaf 3. There will be minor differences. So this is, by design. So we are creating VLAN 11 on this side, and we have this VLAN 10 on this side, so we can see layer 3 communication. Same IRB VLAN. On this side, on leaf 3, we have 100.3.3.3 as our Vtep IP address. BGP configuration, once again, is not going to be much different. We are just going to pair with spine switches, and we are creating this VRF1 here as well. Okay, so I will copy paste this configuration in one go. Let's go to leaf 3. So this is my leaf 3. Let's go to Clish mode or SONiC CLI mode and apply this configuration. Before I do that, let me show you show IP OSPF neighbor. So I have neighborship with my spines. Okay. Okay. Not going to see a lot here at the moment. Obviously, this mapping will be there, but no VXLAN tunnels yet. VRF map. Yep. Show VXLAN interface. That's also a very important command. Looks good. And show VXLAN tunnel. So no tunnel because there is no BGP on the spines. So let's fix that. Spine configuration is relatively simple. So we are creating this BGP protocol configuration. We are creating this dynamic neighborship with this command. And this spines will be route reflector. So I'm using 0.4 here, which is the IP, loopback IP on spine 1. Let's configure it. Okay, so on the spine at the moment we are running OSPF, show IP OSPF neighbor. OSPF neighborship is up. Leaf 1, leaf 2, leaf 3. Let's configure BGP as well now. Okay. And let's very quickly configure spine 2 as well. So the only difference between spine 1 and 2 is going to be the router ID. And that's it. Really simple. Let's go to spine 2. Configuration mode. I just noticed this error message here. So this command was not accepted because it calls a peer group fabric, and this peer group fabric was not configured at this level. So actually this command should come later on. Now because it has been configured, so I can go to configuration mode, router BGP 65,000, and now I should be able to configure it. Should work now. Show BGP L2 VPN EVPN summary. Good. So I've got this relationship up. Let's go to leaf 1. I've fixed this issue on spine 1 as well. On leaf 1, show BGP L2 VPN EVPN summary. And we can see we have this relationship with both spine 1 and spine 2. And let's look at VXLAN tunnel. Show VXLAN tunnel. And we have this tunnel up. You can see this is with leaf 3. Now the interesting thing is going to be on leaf 3. We go to leaf 3. You will see that although there are two switches here, leaf 1 and leaf 2, which are where we have configured VXLAN EVPN. But when I'll do show VXLAN tunnel, how many are we seeing? Only one, because this whole MLAG domain, both of these switches are seen as one VTEP, one virtual VTEP or one logical VTEP. Okay, let's look at what are we learning in EVPN. Show BGP, L2 VPN, EVPN routes. So we are learning 100.1.1. Yeah, we know that. We're learning this MAC, and yes, we're learning 10.1.1.1. Good. On the other side. Okay. We need to bring the 11.1 as well. We can be specific. We can just look at the type 2 routes, type MAC IP, and yes, so we're learning 10.1.1.1. Okay. Okay, so you can see that we are learning it from 0.2, which is our leaf 2, and the bottom of 1.1, and this entry is from 192.168.0.1. This 10 shows this is in VLAN 10. All right, so we can learn the routes. If I go on leaf 1, show BGP, L2 VPN, EVPN route, and let's just focus on type 2 routes. I don't see 11.1.1.2 at the moment. So there is something we need to fix on this side. I believe this connection might be still down. So let me just fix that. Okay, so I just bounced this particular interface. Run this command again. And now you can see we are learning 11.1.1.2, and it was advertised by this with this route distinguisher 0.3, which is leaf 3. Good. So now we should have communication enabled between endpoint 1 and endpoint 2. So let's go to endpoint 2. And from here, if I do show IP route, you can see we have a default route pointing to 11.1.1.254, which is the IP of the SVI on leaf 3. Let me show you that. Show run interface VLAN 11.1.254. Okay, so we'll go to endpoint 2, and from here, let me first ping my default gateway. I can ping it. I'll ping from endpoint 2, I'll ping endpoint 1, 10.1.1.1. There we go. So this communication is working now. Let me do a quick packet capture and look into it. Start capture. I don't know which of these two links is being used, but let's have a look at Ethernet 16 first. Yes, there is some traffic here. ICMP, not V6, ICMP. Okay, so we can see the outgoing traffic is using this link. Let's have a look at one of the packets. So we can see this is in the outer packet. In the outer header, it says it's going from leaf 3, from this VTEP 100.3.3 to 100.1.1, the logical VTEP. The port number, you can see this is the UDP port number for VXLAN. And if we look inside the VXLAN header, we will see that the VNI being used is the layer 3 VNI. Okay. And let's just have a look at the return traffic. I believe it will be using this link. CMP, apply the filter, and look at one of the captured packets. This is traffic. You can see source from 100.1.1, destination for VTep 3. It is VXLAN traffic, and once again VNI will be layer 3 VNI because it's communication between two different VLANs. So this is how you configure VXLAN EVPN when you are using OSPF as underlay and iBGP for your overlay. What I'll do is I will add all this configuration from all these 5 boxes to a file, and there will be a link in the description which you can use to download all the configurations. If you have any questions, please ask in the comment section. Otherwise, we will see you in the next video.